In lecture 5, we will talk about difference in difference estimation, which is one of the most popular and most commonly used methods of causal inference. If you look at the top journals, and not only at them, but at pretty much any economics journal that publishes empirical work, you will see lots and lots of studies that use this method. As we will see, the method, when it's used in its simplest form, is very transparent and very easy to interpret. But when we use it in the form that is currently commonly done, we will also see that things are actually not so easy. But let me walk you through this. The first video in this series of about 5 videos will be on basics. So the classic diff in diff case, what I'm assuming here is that you have already had some experience in panel data econometrics and may have already heard about difference in difference estimation in a prior course. So here I'm just repeating some basic concepts of diff in diff, and I'm doing this based on the classic example in Card and Kruger's study on the minimum wage introduction in New Jersey. So that's the canonical example of a so-called 2x2 difference in difference model. So here what we are studying here is we want to know what is the effect of the minimum wage introduction in New Jersey on employment in New Jersey. And now if you only compare employment in New Jersey before to employment after, the difference is hard to ascribe to the minimum wage because there's obviously over time many things that change, and so we need we don't have obviously a control group. What diff in diff gives us is it gives us a control group, and the idea here is that the control group, the outcome of the control group, moves in the same way, and therefore as it would have been in the treatment group had it not been for the treatment. And if it moves the same way as the treatment group would in absence of the treatment, then the control group provides a suitable counterfactual for the trend in the outcome in absence of the treatment. Now, if this sounds a little bit theoretical, a little bit abstract, let me give you here the example. So this is theory. This is not the actual representation of the data. This is how it would work in theory. Okay? So you see here the blue line is the trend in the employment trend in New Jersey, and New Jersey in 1992 introduced a minimum wage. And if we believe the competitive model of a labor market, then what should happen is when the minimum wage is introduced, that employment should drop. And so what we are interested in is basically this treatment effect here, which is the difference between the employment that we see in New Jersey with the minimum wage relative to what it would have been had it not been for the minimum wage. Okay, so it's a counterfactual exercise, and as we will see, that treatment effect is akin to the average treatment effect on the treated. Right, so I want to know among those, in this case, in that state that has been treated, what would the employment in that state have been had it not been treated. So this is not, we do not use difference in difference to estimate some average treatment effect, because we cannot extrapolate obviously here from New Jersey to any other state in the United States, at least not with this type of approach. So that's the effect that we're interested in, that difference between the employment level that we see given that we have a minimum wage relative to the employment level in the counterfactual world without the minimum wage. Now, how do we construct that counterfactual? Well, we use a suitable control state, and in their case, they use Pennsylvania And if you've ever been to Philadelphia, you would see that, you can see New Jersey from Philadelphia, for example. So these are neighboring states. And so what you can see here is that even before the reform, employment levels in Pennsylvania were higher, but they follow the same trend. And that's what we exploit here. So it's perfectly fine if on average the level is higher. All they need to do is they need to follow the same trend. And basically then that slope here of the employment trend in Pennsylvania gives us the counterfactual slope for the effect in the counterfactual slope for New Jersey, the treated outcome. That's the logic of diff in diff. So we basically project that slope that we can see in Pennsylvania, we project that onto New Jersey, and that's then basically the counterfactual trend in employment. You can obviously see here that there are assumptions needed for that to work, because it needs to be the case that the slope for Pennsylvania after the treatment is the correct counterfactual for New Jersey. And that is by no means clear. This may be true, this may not be true. And this is obviously an identification assumption that needs to be justified by the researcher. Now let's look at this a little bit more systematically. Again, this is the 2x2 model. And I'm showing this not because these days this is how diff is done. It's not. Diff in diff these days is a lot more complex than having 2x2 comparisons. But the issue, as we will see in later videos, is that most people run their diff in diffs that are way more complicated than what you see up here, but they interpret their results like that. And as we shall see, that interpretation is often misleading, and very often it's highly misleading. So we need to apply a little bit more thinking. Okay? But here is what the difference in difference really is about. So you have the difference one, which is pre and post, and then you have the second difference. So inside here you have post and post and pre, and you have then the treated versus non-treated group. Well, these are the two differences that we consider here, and then that if we consider those two differences, so we just take the average outcome of each of those groups, we get the average treatment effect on the treated. Okay? So let's have a closer look at that estimator, how we would usually do that, and what the challenge with diff in diff estimation is. Because obviously any statistical software, when you run a diff in diff estimator with a 2x2 setting, spits out the solution to that formula. But that doesn't mean that actually represents the average treatment effect on the treated that you can see here. And the reason is that so-called parallel trends assumption, the identification assumption that you have to make in order to estimate the average treatment effect on the treated consistently, and to provide an unbiased estimate of that, that may not be satisfied. And you can see this here when we look at those conditional expectations. We can rewrite the first equation here as follows. So we just need to think here that that this conditional expectation is basically the average of the treated group after having been treated. Then that is the average of the treated group before being treated. So that's the same as if that group had not been treated, because it wasn't treated yet. It only gets treated in the post period. So we can write it as the average outcomes of the treated group in absence of the treatment before. Okay, because that's the same as if we say, well, that group gets treated, but it hasn't been treated yet. Okay, so there is no difference between those two states. The difference comes afterwards when the treatment actually happened. And then here in the second parenthesis, well, that's the untreated group that doesn't get treated at any time. So now what we do is to arrive at equation 2 is simply we subtract the average outcome of the treated group in absence of the treatment post. So that's the counterfactual. Right? And then we have to obviously add this to maintain the equality sign. We have to add this back in here. Right? So we subtract it, we add it, and then when you run all those terms, you rearrange things, you arrive at that equation here. Now, why is that term that I've added here so important? Because that is my counterfactual. Okay, that is a hypothetical term which tells me what the average, for example, employment would have been had they not introduced the minimum wage. And now we can also see what the 2x2 diff and diff identifies. It identifies a mix of the average treatment effect on the treated, which is what I'm after, and all these other bias terms. And if the trends after the treatment are the same, right? So if basically the red and the blue dashed line are the same, they have the same slope, then those bias terms cancel out. Okay? And so if we want to provide an unbiased estimate of the average treatment effect on the treated, we need parallel trends in the outcome. Okay, so the parallel trend is here that in absence of the treatment, the treated group would have moved the exact same way as the non-treated group. That's what we need here as the assumption. That's what's called the parallel trend assumption. And if you write a diff and diff paper, a lot of the space you will use and fill with your wisdom will be about justifying why, in your case, the parallel trends assumption holds. And in the remainder of these videos, I will talk a lot about how people justify that in papers, but obviously you have to always follow the latest literature that shows you how people do that. Because it is an identification assumption. So what some people do is what is actually very commonly done is they take a longer pre-period here and say, well, look, until the time the treatment kicks in, there was no difference between the treated and the control group, and the difference only opens up later. And that's possibly a first interesting and useful diagnostic test, but it doesn't prove that they would have moved the same after the treatment, because that's the real assumption here. The important and untestable assumption is that after the treatment, they would have moved the same way had it not been for the treatment. And that's an identification assumption that obviously you can argue for when you show that for many years before they have moved the same way, and then nothing else changed at that time except for the treatment, and then that had an effect on the treated group and led to that divergence. There are actually a few other assumptions here. For example, we should assume that there are, and that also go hand in hand with parallel trends, right? So which is, for example, the absence of spillover effects. right? Because if they were on the same trend, then maybe the minimum wage in New Jersey had a spillover effect on workers in Pennsylvania, and that would have then led to a violation of parallel trends of that assumption. Okay, so there is more to diff and diff than just thinking, well, would those trends have been parallel, and is that plausible? You need to think about things like spillover effects, and as we will see later, also anticipation effects that might actually play a very big role in whether your research design works or not. Okay, now back to that Card and Kruger example. The paper is by now quite old, but still very relevant, especially as a teaching example, but also because it has been quite powerful because they didn't find a significant effect. So what they show is that so they have data there on fast food restaurant workers in both states, which are obviously very much subject to the minimum wage, right? So these are some of the lowest paid workers in the country. And what they show is that after the introduction of the minimum wage, there was a very clear bite of the minimum wage in New Jersey, right? So you see the distribution of wages in both states, and Pennsylvania is the shaded lines, and then New Jersey the black ones, and you see that there is no wages below the minimum wage, and there is a huge spike at the minimum wage. So this means the minimum wage bites, and yet there were no employment effects found, and this triggered a large literature. And where people really have to try to make sense of that is that because we don't fully understand, we don't use the right theory to look at labor markets. So is there, some huge monopsony power that we didn't think about, or is it more that maybe their research design was invalid because the parallel trends assumption didn't hold? And actually, this is a discussion that has been going on since. So this has not been settled yet, and it's not a literature that I necessarily recommend people to go into because it's so controversial. But it's definitely interesting to follow. Okay, so here we see how the diff and diff estimator maps into a regression equation. You can verify this by simply plugging in zeros and ones for whether you are before or after, and whether you're in New Jersey and Pennsylvania. But the basic idea is here we control for dummies for whether you are in New Jersey and Pennsylvania, and then your 2x2 estimator is that coefficient of that interaction, which is 1 if you are in New Jersey and after the introduction of the minimum wage, right? And so that interaction term gives you exactly that, if you remember, it gives you exactly that difference, that difference in difference that you're looking for. So they do this in a very transparent way in their paper by really looking at the two states and what is the effect before and after in each of those states, and that then shows you exactly what the difference in differences is. Right, so you can see here that first of all, even before, the employment rate in Pennsylvania was higher than in New Jersey. And afterwards, it was actually it was still higher, but the gap actually shrunk. And so then the difference in differences between those two dimensions, before and after, New Jersey versus Pennsylvania, is this. Okay, so it actually implies that the introduction of the minimum wage not only did not have an effect on employment, it actually raised employment. And so that, there was a good few economists who said, well, it's very hard to reconcile this with a theory unless you assume there is a strong monopsony power whereby a minimum wage would actually increase employment. But, there was quite some who said, well, if a result sounds too good to be true, It probably is. But again, the jury is still out there on that. Now, I already mentioned that you, as a researcher, if you do a diff-in-diff analysis, you need to provide supporting evidence on the parallel trends assumption. And for that, you need to really provide a visual inspection of, anything that could help you in showing that this assumption is plausible. So you can look at pre-trends, but you have to obviously also note that having pre-trends that are parallel between treated and untreated group is neither a necessary nor a sufficient condition for parallel trends after the treatment. And that's what you actually need. But you can look at the mixtape. There are a good few examples of how people used graphs and showed how the patterns in their data are consistent with the plausibility of parallel trends. So I would refer you to that. So to summarize here, difference in difference, very important method, because all it requires is the parallel movement. So it doesn't require quasi-random assignment of a treatment. All it requires is that the treated and untreated group move the same way and would have moved the same way if it wasn't for the treatment. That's a very popular method. In the 2x2 case that we talked about here, it gives you the average treatment effect on the treated. We will see now in the next videos how this is done these days. Obviously, the literature in the last 25, 30 years has moved on quite a lot, and how results can interpret it when we go beyond that classic 2x2 case.